Hey everyone, let's see this question 25. In it, we have given a statement which is saying that in adversarial search, alpha beta pruning can be applied to game trees of any depth, where alpha is something we have formed so far at any choice point along the path for the max player, and beta is something for we have formed so far at any choice point along the path for the min player, and so on. So, very nice statement. So let's break it down. And first, let's talk about some things that what is a game tree, what is alpha beta pruning, not in detail, but cause alpha beta pruning is an algorithm, so we won't be covering in detail here, but a little glimpse. What is adversarial search? Okay, and what is they saying like there is a max player, there is a min player, and what is all this? So let's break it down one by one. So start with adversarial search. So adversarial search usually we use in 2P games or zero sum game. Okay, what is two player games or zero sum game mean? That there will be two player which will be playing. So let's say for example there is a game of chess. Okay, where there is one player this side, let's say one, and there will be this player who is -1. So either this player will win, so this guy will get one, and this player will lose, so this will get -1. So the sum will be 0, or both will draw, that is 0 0, so sum again will be 0. So one player has to win and other one player has to lose, or one other game can be tic-tac-toe. So there will be either one player will win, other will lose, or both will draw. It can't be possible that both can lose or both can win. So such games that are called two player games or zero sum game, and we use our adversarial search. So as you can see from the name, that adversarial, so both the players will be fighting to maximize or minimize their reward, right? So let's say if we say that this side we place a AI engine, and this side we place another AI engine, and we say whenever you win a pawn or win a rook or get some, I'm using chess terms here, get some positional in advantage, you'll gain more and more. And here we'll say that okay, whenever you do the same, you got same reward but in negative, and we give the objective that okay, you have to minimize the same and you have to maximize the same. So now this player will need to maximize its reward, and this player will need to minimize its reward, because they are programmed that way. It has nothing to do that this minimization mean less. No, they are programmed that way, that okay, its goal is to minimize and its goal is to maximize. Okay, so these kind of search are called adversarial search, where two players are fighting to maximize their reward. Okay, now it can be in negative or it can be in positive. So basically they both were maximizing. One will be maximizing in positive direction and one will be maximizing in negative direction, we can also say that. Now to do this adversarial search, we usually make game trees. So let's say here is some start node of tic-tac-toe. Okay, let's take this example instead of chess. So there's a tic-tac-toe, and then one player will do something, and then again player will have so many possibilities, right? So let's say this is a game of tic-tac-toe, and this was the start. Okay, this was the start, and in this position I drew something. Let's say I drew this. So now this player will have so many possibilities. It can do this, do this, do this, do this, do this, do this, and do this. So there will be so many possibilities, which one the other player will choose, by which its gains or its probability of winning will increase. And again that node will come here, and again the first player's turn will come, right? So we create our game trees like that. So here player A's turn, here player B's turn, here player C's turn, and whatever choices they have, right? Whatever choices they have, thus we create a tree. Same way, if we, let's say there is a chess, so let's say here one player played e4 or move their pawn. Now this player B have multiple choices to move their rook, to not, if we are in a start position, then to move their pawn or to move their knights, and then B player will make some move. Let's say it's plays e5, and again A player's turn will come. So these are, such trees are called game trees. Okay. Now to parse or to predict that who is going to win, we need the value of this root node. Okay. And to get the value of this root node, we have many algorithms like min-max algorithm, alpha beta pruning algorithm, SSS star algorithm, and so on. So one of the algorithm is alpha beta pruning, where what we do, I won't be covering alpha beta pruning in this video, but what we do, that we initialize, so max player, alpha is our max player, right? And beta is our min player. So alpha has to maximize the value and beta has to minimize the value. Okay. Now if you are familiar with programming, so in our early days when anyone is learning programming, we do this program that, okay, given a list of numbers or an array of numbers, tell me the maximum or the minimum of them. And how do we initialize it? So whenever we need to find the maximum, we initialize it with the minimum number we can find, right? And same way for minimizing. If we need to find a minimum number in an array, then what we do, we initialize that variable with the maximum number we can find. So any number who is less than that, we can switch it, and that way we keep doing it, and we find our min. So same way in this algorithm, alpha has to be maximized and beta has to be minimized. So we initialize these values by min, that is, let's say, negative infinity, and by max, that is positive infinity, plus infinity. So initially, let me remove this. Initially, alpha is our negative infinity and beta is our positive infinity. And whenever we get a higher number than this negative infinity for alpha, we update it. Whenever we get a lesser number than infinity, we update our beta. Now let's read the statement again. So in adversarial search, alpha beta pruning can be applied to game trees of any depth, where alpha is the dash value choice we have formed so far at any choice point along the path for the max player. So when we are going through these paths, we will be finding some values. So in these nodes, there will be written some values. Of course, we have find this started this with negative infinity. Whenever we find a larger value, we keep updating it with that value. So at some point, this max player will have the highest value which is found till now. Okay. So far at any choice point along the path for max player, we will know that this is the maximum value because we have initiated in with negative infinity and we are incremented it whenever we are finding a higher number. Okay. And also this is a max player, so you can also get the hint from here. Same way, for a min player, we have initialized it with infinity, and whenever we are finding a lesser number than infinity, we are updating it with a lesser and lesser number. So along the path, we will have the lowest number for our beta value, and also this is for min. So n will be lowest. So our correct answer will be C. Okay. Now if you want to learn alpha beta pruning in detail, you can comment down, and I'll make a separate video on that. That how does alpha beta pruning work and what is the whole algorithm, and we can see game trees and all other algorithms which I have named like min max and FS star in detail on those videos. Okay, till then, thank you. Bye bye.